Hi guys, and welcome back. I had to restart my computer again because it's crashed, because the IDE, the PyCharm, crashed on me. So I'm just going to continue where I left off. I was talking about our data layer interface consists of only two exposed or published methods, and those methods I'm going to write down here are save game and restore game. And because we want to keep our layers separate, we should put these methods into a module. So I already created this module and I've written the code. So it's called oxo data, oxo_data.py, and you will find it within the zipped file. So I have extracted all the zipped file here, and you will find it in the folder called oxo. There are lots of other files there as well which I included, but just follow what I'm showing you to include. So you can copy, for now you can just copy the oxo_data.py in the current working directory and open it in your IDE. So I'm going to explain a little bit what this function is doing, and I'll close the console for now, for the time being. So the first function, _getPath, is a helper function that uses the OS module to try to determine the user's home folder, and if that fails, use the current folder. By convention, functions that are not intended to be called by module users have a leading underscore in front of their name, like _getPath. The save game function uses _getPath to create a new file containing the string representation of the game. The final function, restore game, also uses _getPath to locate the saved file and open it, reading back the stored data. And ideally, we would include a more sophisticated test function or a set of unit tests that we will look into in section 6 when we talk about Python, using Python on bigger projects. So the tests are not shown here. So one note is that in the data module, we have included documentation strings for the module and functions. And you should always do this in your working code. So let's move on to the next step, which is building the core logic layer. We will now create the core logic of the game, and for that we need to define a number of functions that are used throughout the course of a game. However, to know what those functions are, you first need to think about how the game will be played. So before diving into logic code, we need to map out the sequence of play, and for that we can use a sequence diagram. So this is a diagram that is for our game. So the game starts by presenting the user with a menu of options. These will include the options to start a new game or restore a saved game. In either case, once the game has been set up, the board will be displayed and the user prompted to select a cell. The computer then analyzes the move and responds with its own. The board is then shown again until a winner is found. So the sequence diagram for this is shown in the image that you can see here right now. So pause the video. One exercise that I found very useful is that just to copy the diagrams and draw it by hand just to get in the logic in your head. So the sequence diagram is a simplified version of a UML sequence diagram. Each of the objects modules in this case, along with the user, are represented by a vertical line. The arrows indicate messages flowing between the modules and user. The messages have descriptive titles. Some messages are optional, and the conditions that cause them are indicated in square brackets called guards. Some sequences of arrows are enclosed in boxes, and these represent loops or conditional blocks with a description given in the upper left corner. In this case, the main game play sequence. In this case, the main gameplay sequence is repeated until there is a win or draw, or until the user selects quit. If the user selects quit, then the sequence in the box at the bottom is executed. Sequence diagrams are very popular and powerful analysis and design tool. From the sequence diagram, we can see that you need to provide functions to handle the user's menu choices. Only new is shown in the diagram, as well as a function to play the game. The latter would need to return different results depending on the outcome, which is usually a bad idea. However, if you create separate functions for the users and computer's moves, you can then use the same analysis helper function for both of the user and the computer. And with that in mind, we need to write the following functions, and I will show that just in Notepad. For the sake of simplicity. And these are the functions that we need to write. And we also need the helper functions to generate a random move and analyze whether a given move wins the game. And the list of helper function is therefore generate move and is winning move. So once again, to keep the separation between the layers, we should put the logic code into a separate module. And you can either write the code or just load the oxologic.py file, which is included in your files. So it's included here, oxologic.py. Open that up. So the new game function simply returns a new list of 9 spaces. And I hope you have opened up the oxo_logic.py file to follow, and place it in the current working directory and open it from there. As I said, the new game function simply returns a new list of 9 spaces. We also import OS and random and import the OX data module from earlier video. So, and the save game function calls the OXO data function. Of the same name. The restore game function is marginally more complex in that it catches any errors arising because the data file cannot be found and validates the length of the restored game. It could do more data validation on the content of data, but you can add that later if you wish. The generate move function looks for the unused cells in the current game and then randomly selects a cell to place the computer's move. This is not optional, and a more intelligent algorithm would greatly improve the quality of the game. But for now, we'll use this. The isWinning move method is the most complex of the logic functions. This is where the real processing takes place. The approach you take is very simple and relies on the fact that there are only 8 possible winning lines. They can be listed in terms of the indices of the game cells involved, as shown here. To assess whether a move has resulted in a win, we need to check each winning line. We can extract the character in each cell of the candidate line and construct a 3-character string. For a win, all 3 characters need to be either X or O, and this is the function. This is the whole function that does that. And finally, we need a pair of functions that can analyze a user move and a computer move. The former takes a cell value input by the user. The latter needs only the game because it uses _generate move internally. They return the outcome of the move as one of 4 character codes. An empty string means the game is still on. An X or O signifies the victor, and the D means it's a draw. So these are the moves here, the ones we just mentioned. So we could have implemented all of these functions as methods of game class that would have removed the need to pass the game data into each function. Finally, we need a test function. The test function keeps on generating moves until either somebody wins or the board fills up, at which point _generate move returns -1. The moves are generated entirely randomly, so there is no intelligence in the selection. So we can run the code and we should see something like this example. So let's just try it out. Yeah, so it just generated some random stuff because we use the random module to generate the moves. So it's not very pretty, but then it's not supposed to be. Presentation is the user interface, and that's what we are going to talk about next, building the user interface. So what we talked about right now is that we started to think about how the user would perceive the application. That is the user experience. The user experience is the key factor in driving the user interface design. And we need to consider the flow of control from entering the application through normal use to exit. In a command line application, the most common approaches are to offer menus, often nested to several levels, or to accept commands typed at a prompt. In this section of the lesson, we will build a set of very simple menus and create a simple prompt-based solution. So this process will illustrate both techniques while keeping the code size small. So if we walk through the user experience in playing a game of tic-tac-toe, the game starts by offering a menu that allows the user to start a new game, resume a saved game, request help, or quit. The ability to quit easily is an important but often overlooked feature of good user interface design. The quit option just exits the program. The help screen displays a page of explanatory text. Both of the other options take the user into a tic-tac-toe game. Once in that game, the user can either select the cell, save the game, or quit. If they choose to quit while the game is still in progress, they should be asked if they want to save the game first. If they choose a cell, then the computer analyzes the move, makes its own move, analyzes that, and presents the result. If either move results in a win or in all cells being used, then a message is displayed to the user and an option to quit or return to the main menu. The user interface presents the information and manages the flow from screen to screen. It does not perform any of the computational logic that is provided by the core logic layer. So the user interface simply calls the functions that we defined in the OXO logic module. So we start by defining a function to display a menu and return a valid user selection. The function could be specific to the menu and include the menu definition with it. However, it is not much harder to write a function that takes a menu as input and is therefore usable for all menus in the system. So, and you could even extract it to a module for reuse across projects. So now what I want you to do is to get the file that is called oxo_ui.py. Copy that in your current working directory. And open up the file. And we'll go through the code. So, and one thing to just notice that the enumerate function here is used to generate the menu options number, and that they start at 1 because most users find 0 a strange option choice. The function keeps repeating until the user selects a valid choice, with prompts to correct invalid choices. Having presented some choices, we need to write to look at the code to do all of those things. The methods are named after the menu options. So this is where you get the menu choice, and here again it imports import OXO logic file, and which again imports the OXO data file module. So all of these functions are started from according to this menu options. So the next section, execute choice, is a function to process the user's choice, and this can be done using an if-elif chain, but that can become difficult to maintain if there are many options. Although the number of possible choices in this project is small, we use a dispatch table because this is a powerful, efficient, and flexible technique. We also need to change the main function. No, we don't need to change it, actually, it's already written. The main function loops over the menu and game code until the user quits. So, and that only leaves the task of actually playing the game. We need to write a function that takes a starting game position and interacts with the user until the game completes, either because there are no more moves or a winner is found. In addition, it helps if you have a function that displays the game in the usual grid layout rather than the flat data format that we are using internally. So this is the way of displaying the game, and this is the way it's to play the game. So the print game function uses formatting to insert the game values into the display. Note the use of the asterisk star game that expands the list into its individual elements. The play game function displays the user interface prompt for the game screen. You ask for a number representing the cell that the user wishes to place an X into. You also provide the option to quit, and if it is selected, offer the chance to save the game. If the user's choice is valid, you then use the exologic functions to determine the outcome of the selection, and if not, a finishing move to get the computer to take a turn. Notice how all of the rules of the game and the data management are in the lower layers. The user interface layer is dealing with presentation and control flow only. One slight quirk of the design is that the board is passed on into both the user move and computer move functions, but the updated board is not returned by the functions. That is because the board object is a mutable list and as such can be changed by the function, and the original variable will reflect those changes. So later in this lesson we will revisit this game and see how easily we can create a new graphical user interface based or GUI based user interface layer on top of the existing OXO_logic and OXO_data modules. Before we do that, there are a couple of interesting options that we can use to enhance our command line applications, and we'll look at them very soon. But let's just test this game first. So start a new game, and let's start. Save this place. I placed it at 7 and 3, and then I 1. Let's start a new game, and let's quit and save the game. Okay, let's run it again. Play around with it. It's a very nice way of. So I saved the game before I quit the last game. So let's see if I can resume the same game. Yes, I can. I'm gonna get display help. This displays the help. And let's quit. All the options seem to work. 4. It's the quit. So the game logic works, and the UI part of from the command line it also works. So the next we are going to look at is using the CMD module to build the command line interface. And Python has a module in its standard library called CMD that is specifically designed for building command line interfaces. In particular, it creates the type of interface that we use for Python's help and debugger systems. It presents a command prompt, and you can type in a command. You can request help, and the help screen is presented with the list of available commands. If you type help, you get a screen explaining how to use the specified command. So in this section of the lesson, we will build a CMD based version of the tic-tac-toe game from the previous section. It has the same 4 options that we displayed in the opening menu. The gameplay part is exactly the same as before, and you can find the source code in what is called OXO CMD. So if you get that file and put it in the current working folder, so you should have access to the source code. So it imports all the previous modules that we have already played around with. So CMD is based on an object-oriented framework whereby you define a new subclass of the CMD.CMD class. This subclass overrides some key methods to provide your application specific behavior. We then define a set of methods whose names begin with the string do _. The class then interprets the part following the underscore as a command word that the user can type. We can build a skeleton version of your tic-tac-toe game by defining some methods that simply print a message to see how it works. So if you open the OXO CMD module and look at it, and we'll explain what's happening here. So the code that we see here, we create a new class derived from CMD.CMD. To that we add an intro message and a prompt string. We then define the command response methods. Notice that you don't need a help command because that is built into the class mechanism for free. Also notice that you need to provide a second dummy parameter in the method's definitions, even if it's not used in the method. Finally, in the main function, you instantiate the game object and execute its CMD loop. Here. If you run it, we'll see that it produces a fully functional command interpreter applications. So there are many other options and features for you to explore in the CMD.CMD class, but hopefully this example has shown you how easily it is to build a command interpreter style application using CMD. It should also have demonstrated how powerful the separation of the presentation from the logic is. For a very small amount of coding, you have created an entirely different version of the tic-tac-toe game, but the logic and data layers are completely identical. So let's see how this is working. So okay, it says so the logic is the same. So, and it's just a nicer way of using the CMD with the different menus. So now we're going to look at the command line itself and how to read those command line input arguments. So reading command line arguments, when you start a command line program, the command line itself is stored as a list of strings in sys.argv. The first element is the script name, and the following elements are arguments to the command. Thus, if you had a file copying script, you might call it like this. Let me show you in the command prompt instead. So this is how you would use with the reading command line arguments. And in the code, this is how you would use the script. And the code for in Python would be for our sysargs, for example. This would be the sys.arg value. However, it's often the case that command line scripts take optional arguments to control the display or functionality. For example, many programs offer a -h or --help option that causes the command's help information to be displayed. You can process those options by examining the contents of sys.arg, but it's a non-trivial task, so Python includes the arg parse module to assist in handling these kinds of command options. So we'll now modify the original tic-tac-toe game to display the help message if either -help or --help, and it is specified on the command line. It also goes direct to a new game if -n or --n is specified, and it goes straight to a restore game if -r or -r or --restore is given. This enables experienced tic-tac-toe players to bypass the initial menu if they wish. So one note is that Python argument processing assumes Unix-style arguments, that is, they start with either 1 or 2 hyphens. The traditional option style on DOS or Windows is a /. Argparse does not process those arguments by default, but you can specify prefix characters as an optional argument, then creating the parser if you need to support other styles. So go ahead and open the oxo_args_ui file that's included in the oxo folder, and you will see that in the main function, that is what's different from the application before, without the args version. So let's try this file out. Or we should have actually tried it here. to the correct so if we try to start our file, so we get the help functions. If we want to start a new game, we do and if we quit and save and we go restore game, should work. Yep. So this is just another way of creating the same game. So when we use the our game or program this way with the args, sys.args, and if we specify -n or --new, it goes straight into a new game. Specifying -r, -r or --restore brings back the last save game, as we just saw. You should notice a couple of features of the arg parse code. Let me just get that. This is section here. First, we created the options as a mutually exclusive group. That was because it makes no sense to specify both new and restore options in the same command. Also, we provided a description of the program in the constructor of argument parser, and this then appears in the help screen. Finally, by specifying an action of store_true, which is shown here. We made the options into Boolean flags that enable them to be used as truth values in the if-elif tests. The argparse module has many other tricks up its sleeve. It can interpret arguments as different types, it can count options, and it can associate multiple options, and so on. So there is a tutorial on its use, and the documentation has several examples. So, and the last thing to point out here is that we have effectively given our code yet another user interface mechanism without any modification to the game logic or the data layer. Separating presentation from logic and data is a very powerful design technique. So in the next lesson, we are going to look at a different way to make a command line application more professional looking for our users by adding a few GUI features while not implementing a full GUI application. So in the next section, we'll get into the more visual stuff with the GUI, to work with the take-hinter library. So see you in the next lesson.